Good afternoon, my name is Andrew Gavin, and I'm here to talk to you about a tool I wrote about a year ago and I've been updating ever since. It's called OpenDLP, and how you can use that to steal sensitive data from thousands of systems in less than an hour. So just a standard disclaimer, I'm here just representing myself. Even though I work for Verizon Business, they have nothing to do with the tool, nothing to do with the presentation. And also, if you use my tool and you get in trouble, not my fault. So my outline here, I'm going to talk about what OpenDLP is for those of you who aren't familiar. This is, by the way, building on a presentation I gave at ShmooCon earlier this year. My reasons for writing it, how the agent portion works. I'll show benchmarks between the agent and the agentless scanner, and you can see the drastic speed improvements that an agent offers. I'll give a live demo of the agent and also a live demo of some new features. I've got 4 demos lined up. I plan on flying through these slides because I've got a lot. I don't have much time, but I do have quite a few slides, and I hate slides. I like demos. So, and then at the end we'll do I'll show my contact info, and we can have a few minutes for Q&A. So, what is OpenDLP? For those of you who don't know, it is a data discovery tool, and there are 2 components to it. There's a web app that kind of controls everything, and that's on the LAMP stack, so Apache, MySQL, and Perl. And then there's a Windows agent that runs on, obviously, Microsoft Windows. And it's open source, released under the GPL version 3, and it is useful for compliance people. So if you're like a PCI guy, you want to find out where your PCI data is, you would want to use this. It's also good for proactive network and system administrators because we all know they are proactive, right? And then finally, the coolest thing, what I do, I'm a pen tester, so I really wrote this for myself, and I use this after I get domain admin, and then I just let this thing rip on the entire network, and it's pretty cool. So, what was my reason for writing it? Well, there really was no free agent-based solution last year when I started this. And the only solutions were really GUIs that you could run on your desktop, like Cornell Spider, and you could hack those to be an agentless scanner where you would do a net use to the remote hard drive and mount it locally. But as you'll see with the benchmarks, it's not really ideal for a very, very large deployment. It's going to be very, very slow. So how does it work for the agent-based scans? How do you get it going? Well, the first thing you want to do is you want to create a policy, and this policy is going to be reusable. You're going to have your administrative credentials because the agent runs as a service, and you need to be an admin on the box to install a service. And then you can do other things like whitelist and blacklist files and directories. And then you want to configure your regular expressions that you're going to use. It uses PCREs. I assume we're all familiar with that here. And then a few other things that I'll show. Then you're going to start a scan, and you're going to, it's going to be deployed over SMB, and it's going to get kicked off by the WinExe program, which is like the Linux PSExec, and it can concurrently deploy the scanners up to as many as you want in parallel. So instead of just sending out one at a time, you can send out maybe 30 or 50 at a time just to get it going faster. Now, when the agent is running on the Windows boxes, it's going to run as a service, as I said, but it'll run at low priority, so no one's really going to see or feel it. There's not going to be a little pop-up GUI box or nothing in the system icon tray or anything like that. It's also going to limit itself to a % of memory. So if you want to scan some huge 10 gig file and the Windows box only has a gig, and you try to load that 10 gig file into 1 gig of memory, bad idea. So what it'll do is it'll chop up that large file into smaller chunks that's defined as a % of system memory, so like 10% of system memory or 20% or whatever you decide to use. Finally, when it's done, well, it's going to scan, it's going to go through the whitelist and blacklist and then scan the resulting files. And then every so often it's going to ping back to your web app with results, and it'll give little status updates and stuff. And this is done securely. It's over a 2-way trusted SSL connection, so if someone tries to man in the middle it, it's not going to do anything. It's written in pure C. There's no .NET requirements, so if you want to run this on an old Windows 2000 or XP box that doesn't come by default with .NET, it's still going to work. And finally, when it's all done, it's going to uninstall itself automatically as a service. It's going to delete its directory completely. Really, the only way that you'd notice it was there is by looking at the logs, and certainly 99% of the Windows users won't even notice it was there in the first place. In the web app, you can monitor the agents, and as I said before, it's going to ping with results every so often, and you can see how many files and bytes it's processed. You can control the agents, pause, stop, uninstall, resume the agents, and you can also view the results live as they're coming in. You can, if you see a finding, you can download that file just to verify if it's actually there. there'll be a little hyperlink there, and it'll tell you the byte offset inside the file where it thinks it found whatever regular expression. Like I found a Soc number at offset 500 in this file. So I know what you're thinking. Yeah, I invented multiplayer grep, but someone, I guess, had to do it. And just to go through some benchmarks, these are the specs. It's a couple of years old machine, but just for the sake of this benchmark, I ran it on 2 gigs with 13 regexes. It took just over an hour and 7 minutes. I'm not going to go through the rest of this, but on the flip side, an agentless scanner, the same exact thing took an hour and 20 minutes for 13 regexes. And for the agentless scanner, of that time, about 20% of the time was spent downloading the files, because with an agentless scanner, you basically have to download the entire file system to your own box so you can process those files. So 20% of the time was spent on that, and nearly 80% of it was spent on crunching the numbers. Now, if you're going to do this for more than one box, more than one target, you're going to run into some bottlenecks, and probably the biggest bottleneck is going to be your own system's CPU, and that's what's really going to slow things down. So just for one system, it's only really 19% slower, but if we extrapolate this to more systems, we see here the blue line is the OpenDLP agent remains flat, just about 1 hour. And the agentless scanner with 1 core for 25 systems will take over a day. Just 25 systems takes over a day. Oh, sorry. So on the bottom, there's really not much information. It just says, for this graph, it shows from going from 100 to 2,000. Sorry about that. So for 2,000 systems, which is way on the right, it'll take almost 3 months to scan 2,000 systems with a single core system that I use my benchmark on. But with the OpenDLP agent, it just takes 1 hour, and you can't see that, but trust me, it's there. So it just remains flat. The upsides to an agent-based solution are that all the computations are done on those victim systems. It's basically a distributed project. It's like CD, but instead of searching for aliens, you're owning data. And it also doesn't have much network traffic. It's only sending out about 1 meg initially with the agent, and then every so often it pings back with those results and the log files. So it's really not a whole lot of traffic. The downsides to the agentless scanner are, of course, everything has to be processed by you, by your own laptop or your own system. So if you're going to do this 2,000 times in parallel, it's really going to crush your CPU. And of course, you have to download everything to your system as well. So I'm going to show a live demo of the agent. And this is the interface. Make it a little bit bigger. And what you first want to do is you want to go to the profiles, and you want to create a new profile. So for this, we'll just call it agent. And we'll select the Windows file system for the agent. And you can mask or unmask sensitive data. I don't like to mask sensitive data because that's lame. So we want to do the local administrator account with the secure password of blah123. You have to specify the domain or the work group. If you don't have the password, though, if someone sent a patch to me, you can put in the SMB hash. So even if they've got like a 64-character long NTLM password that's super complex that Rainbow Tables won't even touch, no problem. Just put in the SMB hash and you're good to go. The install path, this is kind of important because when the agent is uninstalled, it'll recursively and forcefully delete this directory. So please do not install it to the Windows directory or anything like that. You've been warned. This is the memory limit that you can set where it'll chop up the files. Here's where you can whitelist and blacklist directories. So I've got some sample data in this directory. And likewise, here's where you can whitelist and blacklist file extensions, so pictures, movies, EXEs, things that you really probably don't care about that would contain sensitive info. Here are the regexes, so we'll check some of these. You can add your own regexes. As I said, they're based on PCREs. These options here tell the agent what regexes to treat as credit cards. So if it thinks it ran across a 16-digit number, you might think it's a Visa or MasterCard, but it's going to run that through the mod 10 check. Yeah. Yeah, exactly. That's what this is exactly. So it'll cut down on false positives. And these options here, it'll read inside zip files. So Office 2007, OpenOffice, just normal zip files. It'll pass them over once as a normal file. Then it'll try to unzip them and go through its contents a second time. This is the upload URL, and the It takes basic authentication credentials in addition to the certs, so I don't want to fat finger it, so I'll copy paste. This is the time between uploads, so how often it'll ping back, and we just fill out this stuff and submit the new policy. Now we want to go to start the actual scan. So we'll just name this agent. We select the profile that we just created, and we enter our guinea pig here, and it's going to start. So if you were to scan maybe 1,000, 2,000 systems, on this screen you would see a live scroll of this here saying 0 systems remain, or 500 systems remain in queue, 400, 300. Once you get down to 0, then you know it's safe to leave this page, because if you leave this page before, then it might interrupt the deployments. So if we go back now to our guinea pig system, we can see that OpenDLP is running below normal. It's going to run as a service, and let me try to bring that up. Oh, it's just done. But we see here it's running as a service, and eventually now it's gone. So when it's done, or even while it's running, you can view the results live. So you just go to the view scans and results, and this is it's going to give you a summary of the scans here, and you select one, and here it's going to give you all the systems in that one scan that I just launched. So there's only one system, and we can view the results here. So we found possibly a SOC number, let's say in this file here, so we can click it and we can download it and open it. And we see, yeah, there's probably a SOC number, the number 1s, number 2s, and then down here number 3s, so we can verify that. If you think you found some false positives, you can check these guys and scroll to the bottom and just mark them as false positives, go back, they're gone. And if you think you accidentally marked something as a false positive, you can manage your false positives here and just drill down to the system and uncheck a couple. Now they're not a false positive. We can go back to the results and refresh, and they're back now. So that's pretty much it for the agent scanner. Let me go back to my slides now. Recently I added some new features though. I gave a talk in Amsterdam in May, and I added database agentless scans. So I've got support for Microsoft SQL Server and MySQL, and then most recently, right before this conference, I added agentless support for Windows and Unix. So for the database scans, it's very, very similar to creating a policy for an agent scan. The only difference though is that instead of whitelisting and blacklisting files and directories, you can whitelist and blacklist tables, databases, and columns. That's pretty much the only difference. It's going to run as a shell script, a Perl script, on your own system in the background, and it's going to walk the database structure just like you would walk through a SQL injection. So it's going to enumerate the databases and the tables and the columns, and then it's going to go after the data. And then you can control the scans too. So I'll give a quick demo of that. So we're going to create a new profile again. We'll call this MySQL. And test and test. And here's where you can whitelist and blacklist your databases, your tables, your columns. You can limit how many rows you can grab. So if you want to grab all rows, just enter a 0. But if you're going to be aware that some tables are quite large. If there's a million rows, it would take a while. So we'll submit that, and we will launch our scan just like we did last time. Select the profile that we just created. I'm going to cheat and just do loopback because I didn't bother to set up MySQL listening on 3306. So this is going to go pretty fast. In fact, it should be done because there's not a lot of stuff. Here is the scan that we just ran, and we see that it's done.